Hey, Corbin. Thanks for asking me these questions. I like how you are challenging yourself and going to get some volume of some cones. I think that's awesome. First off, real quick review. Remember, if you're getting the volume of a three-dimensional shape, if the shape has sides that are straight up and down, like a rectangular prism or a cube, then you can simply get the area of the top or bottom, right? And remember in geometry, they'll call that the bottom, the base. They'll call it with a base with a big B, means the area of that base. And then times how tall it is. So for this cube, remember it's 3 times 3 times 3. That top layer you can see is 9 cubes. And there's 3 layers, so 3 times 9 is 27 cubic units for the volume of this, okay? And I don't know if you caught it, but earlier today I was talking about that's true with any shape with straight sides. That means with straight up sides, 90-degree sides, vertical sides, right? And you can do that with a triangular prism, right? Right. If you have a triangle on top and a triangle that's the same for the base, get the area of that triangle times how tall it is going to be the volume, right? And the cool thing about a cone, it does not have sides that go straight up and down, right? The height is straight up and down, that's in the middle, but these come up almost like a pyramid, right? Right. But here's the cool thing. I think you saw me say that a cylinder is kind of like a circular prism, right? It has a circle on top and the same exact circle on the bottom. And if you get the area of that circle times how tall it is, that's the volume. Well, the very cool thing about the cone, for me, I just think it's amazing, is if you were to get a cone, okay, you can get the area of that circle, times it by the height. That would be the area of a cylinder, right? The cone is exactly 1/3 of the volume of a cylinder. Okay. So that cone, if that was a cylinder instead that went up the same height, had the same circle on top as the bottom of the cone, the volume of that cylinder, right, compared to the volume of the cone is exactly 1/3 of that volume, which is kind of cool. It's exactly 1/3. Okay, so looks like you were figuring out the volume of that cone. Very good. Real quick, I did see a math problem where you're doing 8.5 times 4 off to the side, and you made a mistake on that one. So just want to say real quick, if I saw 8.50 and I was going to multiply it, I would just say, let's do 8.5 instead, have one less digit, because that's just going to be a 0 in the end anyway. But it doesn't matter that much. It makes it a little simpler. Whenever I could take a shortcut and make it simpler, I will. But let's pretend I didn't. You go 4 times 0. First off, I'm pretending there's no decimal there. So I'm pretending this is 850 times 4, right? So 4 times 0 is 0. 4 times 5 is 20. I put the 0 here, carry that 2. Okay, from your paper, I was having trouble seeing that. And then 4 times 8 is 32 plus 2 more, 34. Okay, you ended up with like a 314 there. Now, because I left that 0 there, I have 2 digits to the right of the decimal in this problem. So I have to go back 2 digits in my problem to put the decimal in my answer. Okay, so that's 34. Now, if I pretended this was 85 and chopped off that 0, I go 5 times 4 is 20, carry the 2. 4 times 8 is 32, plus 2 more, 34. And this time, I only move the decimal over once, right? So I only have to go back once. So you get up with 34 on that one. Okay, now let's look at the numbers you actually had for the cone that you made here. So for your cone, you had the line going all the way across. See how I put the R there? The R is the distance from the center of a circle to the outside, and that R stands for radius. But your line that was labeled went all the way across through the middle. Okay. And you had that labeled 10. 10 isn't the radius. 10 is what's called the diameter. Okay. So if the diameter is 10, the radius is going to be half of that. That's going to be 5. And it looks to me like you had a cone and you correctly figured out that the radius would be 5 if the diameter is 10. And you had a height of that of being 20, right? So it looks like you were doing the correct formula, right? The area of the circle, and the area of a circle is the radius squared times pi. And the radius squared is 5 squared, 25. And you have to go 25 times pi. And it looks like you used the most popular estimate for pi of 3.14. Just remember, that's not pi, that's an estimate. You could have used 3. You could have said 3 times 25, that's 75. 75 times 20, right, is 2 times 75 with another 0, right? And so you could have said that's about 1,500 is the area of the circle times that, but that would be for the cylinder, right? Right? And now I have to do 1/3 times that. And remember, the word in math that means times, one of the words is of. Okay, and sometimes I tell kids cross out that of, make it a times, but in this case I'd say let's treat it as of. What's 1/3 of 1,500? 500. So it's going to be about 500. Now we're going to get closer, right? Because we're using 3.14 for pi instead of just 3. Okay, and let's go do that math real quick. I think you did this one right. Let's just double check. I'm going to pretend like it's 314 times 25. 5 times 4 is 20. Carry the 2. 5 times 1 is 5 plus 2 is 7. 5 times 3 is 15. Now I'm going to put a placeholder because I'm doing 2. That's really 20, right? I'm going to cross out any tally marks so I don't get confused. Okay, whenever I do 2-digit or 3-digit, I make sure I cross out tally marks in between. And 2 times 314 is 628. I can just do that part. Okay, now when I add, I get 7850, but really that wasn't 314. That was 3.14. So I went over 2 spots in my problem. I got to go back 2 spots in my answer. So instead of getting 75, the area of that circle when you use 3.14 is 78.5. And you did get 78.5, right? Because I saw you had another problem, 78.5 times 20. Okay. Now I'm going to pretend it's 785. 0 times anything is itself. I can go 0 times 5, 0 times 8, 0 times 7, then go put a placeholder and go 2. But you know what? It ends up being the same thing. I just put the 0. Then I go 2 times 5 is 10. Carry the 1. 2 times 8 is 16 plus 1, 17. Carry the 1. 2 times 7 is 14 plus 1 is 15. Now, I got to go back to my problem. That was 78.5. So I moved the decimal over once to start my problem. I have to go back once to get my answer. That's 1,570. And that looks like what you got. Yeah. And then the next thing you're going to do, since this is volume, we're talking about cubic units. So if it was inches, it'd be cubic inches. Okay. Let me go check out your other problem. Okay. And looking at that again, we have to make sure we take 1/3 of that, right? So that's the 1,570. That would be a cylinder with that same circle, that same height. But the cone, right, is 1/3 of that. So it looks like I do see you divided that by 3, and 3 goes into 15 5 times. Perfect fit. Bring down the next number. 3 goes into 7 twice. Bring down the next number. Goes 3 times. And then you recognize 3 times 3 is 9. That when I add a decimal and 0, I'm going to keep doing this, huh? I'm going to keep going 3, right? So this ends up being 0.33333333, right? What you can do is have your remainder, if you want a fraction, 0.333 with a decimal. That's going to be, you're really estimating. If you want it exact, then you are going to make it a fraction, right? 523 and 1/3 is the actual volume of that. Now I saw that you wrote down surface area of spheres. I didn't see any problems for that. Okay. Don't forget to meditate and don't forget to exercise. I like seeing that on there. And I hope that's yours. But if your parents, that's fine too. Meditation is good for you, right? Yeah, breathe. I like all those notes. If you did do a surface area of spheres, send it to me. I'd love to look at it. Okay, good job. I like how you're challenging yourself, and I appreciate you asking me questions.